So hello guys, my name is Edison, and in today's tutorial I'll be showing you how to connect your USB flash drive to your STM32 MCU. As you can see from the video, you can see that I have the USB port which is connected to VCC and ground. Then on the other side is connected to data plus and data minus. Then I have these two LEDs. One is connected to pin PA5 and the other one is connected to pin PA6. So I'll be showing you how to create a folder in the USB. Then inside the folder you can create a text file and write something inside the text file. So I'm going to create a new project. And then I'll select my board that I'm using. I'm using a 446RA. You can initialize peripherals in their default mode. So clear out the pinouts so that you can configure again. And then I have pin PA5 which is connected to one of the LEDs. So I'll call this flash status, and pin PA6 I'll call this write status. Then from there I'll go to system core and RCC. I'm going to enable the external oscillator. Then under sys I'm going to use another time base. Make sure that you change the time base to another timer. Then from there I'm going to connectivity OTG full speed. Then select host only mode. And then I'm not going to activate the VBus because I have already powered my USB externally. Then under middleware, go to USB and select the mass storage host class, and then go to FATFS. Then select USB disk. Under USB disk you are going to change this to enable mode, the change attribute function. And then from there you enable this with fget current working directory. Then you're also going to change the maximum sector size to maximum as possible. Then from there you go to clock configuration. Make sure that the frequency to the USB is 48 megahertz. So I'll resolve the clock issues, and you can see that the frequency to USB is 48 megahertz. Then I go to project manager, give my project a name, USB host mode, mass storage, and I'll be using Keil uVison, so I select MDK ARM, then generate code. Then you find this error because we not configure the VBus. So I'll just go ahead and generate the code. Then the project is generated successfully. Open project. Then under application user call, open the main, then first build the project. So from here we go to FATFS app, Then you're going to copy this to the main under private variables, and then you're going to declare them as external. And I'm also going to add a variable of result res. Then I'm going to add another variable int bytes written. Then I'll have int dir flag. I'll also have an array of character that can hold 100 characters. So from there, under the main loop, this is where you shall start writing your code. And the first thing I want to do is go to USB host app under USB host.c. I'm going to copy this to my main, and I'm going to declare this as external. And another main, I'm going to use a switch case. Switch Apple state. Then we have different cases of Apple state. Case 1 is case application idle. Then case 2 is application start. This is when the USB is mounting. Then case 3, we have application ready, and now the USB has fully mounted. It is ready to receive a read or write operation. Then you have case application disconnect. So this is when now you have disconnected your device, your USB flash drive. So when you have not connected your USB drive, I want to go the green LED. So this is the flash status, GPIO port, then flash status, GPIO pin, and then I'm going to toggle it at every 100 milliseconds. Then when the device is mounting, I want to test if device is F mount. We are mounting the device, USB, FATFS, USB H, FATFS, and then we have constant. We have the path, which is USB H path, and this is constant. And then the first parameter is either 0 or 1. So if this is okay, if the device is fully mounted, we are going to reset the flash status LED. The flash status GPIO port and the flash status GPIO pin, then GPIO pin set. We are going to reset, so it is pin reset. Then when you have fully mounted the device, it is ready to receive the write or read operation, you are going to set the blue LED that is now the write status GPIO port and the write status GPIO pin, and we are going to set this GPIO pin set. And then when you disconnect the device, I'm going to reset this. You reset the write status LED, and then you continue toggling the flash status LED to show that there's no device that is connected. So let us build the code. So let's flash the code to our board, and then when you reset the board, you can see that you have the green LED blinking at toggling at after every 100 milliseconds. I'm going to insert my device. So you can see now you have fully mounted the device, and you have the blue LED on and the green LED off. So when I disconnect this, you can see now we have back the toggling of the LED, and the other one goes off. So when the application is ready, I want to create a folder, and I'm going to use a function called fmake directory, and the directory name will be of type constant, and I'll give it a name ADC, and maybe we can test this. If this is successful, then we want to go to that directory, so we change the current working directory, and go to that directory which is ADC, and if this is successful, then we want to set our LED inside here. So from there, what we want to do is create text file inside the ADC folder. So I'm going to use fopen function. So this guy takes the file pointer as the first parameter, then the second parameter is the path, so the path is the name of the file, so I'm going to call the name adc.txt, and then I'll have the byte mode, so it's write. So we are writing, we are opening the text file in write mode, or if it exists we can append to the already existing file. And we can also test this. If this is successful, so we can use printf to cast a string to the buffer, and it will be stored in hold, and then it is of a string type. Then we shall just write adc values not present, and then we are going to add a new character and a carriage return so that we can print in a new line. So then you are going to write this to our file. So I'm going to use the fwrite function, and this takes the USB H file, and then we have the buffer, the buffer is hold, and then from there we have the size of the buffer. It will be the string length of hold, and then we have the bytes written, and we can also test this if this is successful. Or maybe we can assign this to a value which we declared, that is result. So then we can come here and say that if result is not equal to frok or bytes written equals to 0 if it writes nothing to the file, or you can have return 0, or we can have else. We can have now this LED toggling. We can make it toggle for 3 times, or we can just use a for loop for int n equals 0 and is less than or equal to 5 and plus plus, and then this is just a for loop to iterate 5 times. So we want to set this and reset, so we can set and then reset, and then we shall have a delay of 100, maybe 300 milliseconds this time. And I'm going to copy this here. So if the write is successful, we shall see it blinking or toggling for 5 times. Then from there we are going to close the file that we opened. So when you open a file, you have to close it to prevent it from getting corrupt. So sad USBH file. So these, the USBH file and the USB FATFS, these are the values that we imported here and declared them as extern. So from there we can build the code for testing. So 0 errors. Let's flash our code to the board, and let's manually set the board and connect our USB. You can see that the blue LED is blinking. That means it is writing some data. So if you remove this and insert to your PC, you can see that we have the folder that we are called ADC. Inside the folder we have the adc.txt, and when you open this, you will find that ADC value is not present. And you can see that inside that folder it created another folder and created another folder. So to make it only create one folder, that is why I had defined a character flag, an integer flag. So I'm going to use the flag. So inside here and say if directory flag is equals to 0, then that is when I want to create the folder. That is when I want to create the folder. So when I create the folder and move into that folder, I just want to make sure that directory flag is equals to 1, so it will not come into this loop again. So let's build the code. Let's download the code to our board. So let's insert our flash disk again. It is now writing. So let us remove our USB and plug in into our PC. So you can see we have the ADC folder, and inside the ADC folder we only have one text file, and inside that text file we have ADC value not present. So that is it. So next time I'll come with the tutorial on how to read from the USB. So thank you, and I'll see you in the next tutorial. Don't forget to like, share, or even subscribe.